Hello and welcome to Honors Functions. In this lecture, we're going to be covering an important notation that we use all the time in math. It's called the sigma notation. We use this notation to represent a sum. Let's begin. So suppose you have a sequence of real number that I will call ai from I equals 1 to infinity, and you want to add the first n terms of the sequence. So we're looking at a1 plus a2 plus a3 plus etc etc etc, and I will stop at n. So here I'm adding n terms of the sequence. We've denoted this sum by Sn, capital S subscript n, and that's fine, but normally we would use a sigma notation for it. So this sum is going to be denoted by sum or sigma. This is the capital Greek letter sigma. Okay, it stands for sum in math. From I equals 1 to n of ai. This is how we write the sum. I is called the index of summation or the dummy index. 1 is called the lower limit of summation. N is called the upper limit of summation. Limit right here, okay, lower and upper. And ai is called the general term of summation, general term. We also use the word argument or the word summoned. Okay, so general term, argument, summon, same thing. It doesn't matter what you're using for I, for the index right here. I could rewrite the same sum by sum from k equals 1 to n of a sub k. Okay, or again, sum from s equals 1 to n of a sub s. It stands for the same thing. You do not have to start at 1 right here. You may want to add the n terms after the 10th one, for example. Okay, so we can write sum from I equals, so if it's after the 10th term, you start on the 11th, right? I equals 11, and here it's going to be 10 plus n. I want to add n terms after the 10th one, right, of ai. So what is that? This is a11 plus a12 plus etc etc plus a10 plus n, right? And so how many terms have you added? This is 10 plus 1 right here. So from 10 plus 1 to 10 plus n, you've added 10 terms. So again, you don't have to start at 1. Finally, an important remark. What about if my general term here, okay, is not a function of the index? What does that mean? Well, it means that you take the sum of k n times with itself. Why? Well, this is the same as sum from I equals 1 to n of k times I to the 0. I to the 0 is 1, right? So it doesn't matter what I is, anything to the 0 is 1. So what is this equal to? So this is k times 1 to the 0 plus k times 2 to the 0 plus k times 3 to the 0 plus etc etc plus k times n to the 0. Now, of course, all these power zeros are 1, and so it is k plus k plus k plus k. And how many do you have? 1, 2, 3, n. You have n replicas of k, n times k. So this is an important property, okay, and it will show up in some of the problem. Let's go over some examples now. So in the first example, it is a sum from k equals 0 to 6 of 2. So my general term 2 is not a function of the index k right here. Therefore, what that means, it means that I'm adding 2 as many times as I have terms between 0 and 6. How many terms between 0 and 6? 7. So you're adding 2 7 times. 2 plus 2 plus 2 plus 2 7 times. So it's 2 times 7, so it is 14. Let's move on. So in the second example, what do we have now? Now the general term is the function of the index. So what is this? If k equals 0, 2 times 0, plus if k equals 1, 2 times 1, plus k equals 2, 2 times 2, plus etc, 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 plus 2 times 6, right? So basically we can factor 2 out, and it's 2 times, so we're not going to write 0. So we start with 1 plus 2 plus 3 plus 4 plus 5 plus 6. That's it. 1 and 6, 7, 7 and 7. So 21 times 2, 42. Here we go. Pretty nifty, huh? All right, next example. All right, example number 3. So let me see what this one is made of. If k equals 0, you have 2 times k minus 1. So 0 minus 1 is negative 1. Plus k equals 1, 2 times. So 1 minus 1, 0. Plus 2 times. So we have k equals 2 now, right? So 2 minus 1, 1. 1 plus 2 times k equals 3. 3 minus 2, 2 plus, okay, I think I know what's going on. The next one will be 2 times 3 plus the last one will be 2 times k equals 6. So 6 minus 1, 5, right? Okay, let's factor 2 out. It's 2 times, so negative 1 plus, so the 0, of course, I'm not going to write it. And I will have 1 plus 2 plus 3 plus 4 plus 5. That's it. So 1 and 5, 6, and 6, 12, and 3, 15, minus 1, 14, times 2, 28. Next example. Okay, so in this case, the summand, the general term, is the same as before, but my lower limit and upper limit are different. So what is this? I'm starting with k equals 1, right? So it's 2 times 1 minus 1, 0, plus k equals 2. 2 times 1, plus 2 times 2, plus, okay, what's the last term? K equals 7, so 7 minus 1, 6, 2 times 6. This sum is the same as the one in example number 2, I believe. And that sum was 42. Okay, let's move on. You do number 5, 6, and 7, and I'm going to do number 8 and 9. All right, so these ones are a little bit more complicated now. Number 8. We're going to have to be careful right here. Let's write this sum. You don't have too many terms. You have 6 terms, right? Okay, if I equals 0, negative 1 to the 0 is 1 over 0 squared, 0, 0 plus 1, 1. Okay, if I equals 1, negative 1 to the 1 is negative 1 over 1 squared, 1, 1 plus 1, 2. If I equals 2, negative 1 squared is 1 over I equals 2. So 2 times 2, 4 plus 1, 5. I equals 3, I will have negative 1 cubed is negative 1 over 3 squared, 9 plus 1, 10. I equals, almost there, guys. I equals 4. Negative 1 to the 4 is 1. 4 squared, 16 plus 1, 17. And the last one is I equals 5. So plus minus 1 over, and 5 squared, 25 plus 1, 26. Okay? So the sum is just 1 minus 1/2 plus 1/5 minus 1/10 plus 1/17 and minus 126. So you can take your calculator, but let me show you how to enter this in your calculator. Okay, let's go. Let's take the calculator. So here we go. Here is a calculator, and to enter a sum in your calculator, you need to go to the math menu right here, and you need to go down the math menu until you find sum, the sigma notation. And the summation, oops, I passed it. So actually, let me go up. It's going to be faster if I go up. Right here, It's 0 right here. Summation notation with sigma, so it is 0. Here we go. Summation notation. So what index of summation will I choose? Well, personally, I will just take A, okay, because it's the easiest to use. The sum was, the lower limit was 0, and the upper limit, so I'm going with the arrow right here, the upper limit is 5. Now, the argument is, so negative 1 to the power of A, so we need to put that in parentheses, negative 1 to the power of my summation index, that's A, so alpha math, that's A right here, and that gets divided by, so we need to open a parenthesis because we have a sum right here, so the index to the power of 2, so that's A squared plus 1. Okay, let's close the parenthesis, and I think that's it. Yep, that should be it. Enter, and we find this number. Let's try to frac that. Fraction, enter, and yep, we have it, 1371 over 2210. So the sum is 1371 over 2210. Here we go. Let's move on. Let's go over the next example. Number 9. Okay, so this sum looks like the previous one, actually. Same limit of summation. The only difference is this part right here. In the previous sum, that was I squared, and now it's 2 to the I. Okay? So let's get the sum. So we know what's going on the top, right? We're going to have a sequence of plus 1, minus 1, right? So it's 1 over, minus 1 over, plus 1 over, minus 1 over, plus 1 over, minus 1 over, right? I think they're all there. I equals 0, 1, 2, 3, 4, 5. Yep, they're all there. Okay, so now let's just get the denominators. 2 to the I, 2 to the 0 is 1, 1 plus 1 is 2. I equals 1, 2 to the 1 is 2, 2 plus 1. I equals 2, that's 4 plus 1, 3, 8 plus 1, 4, 16 plus 1, 5, 32 plus 1. So it is 1/2 minus 1/3 plus 1/5 minus 1/9 plus 1/17 minus 1/33. Here we go. This is a sum. So to find it, of course, I'm going to enter it in my calculator. But because it looks so closely to the previous one, I'm wondering if we could just change this one right here. So let's grab it, enter, and let's just change. Let's go in here, right here, and let's just change what that looks like. The power should be A, right now, while the base is just 2. That's it, right? I think that will do it. Okay, let's enter that. And let's try to frac this. Math. Frac. Yep. Okay, let's see if it works. And oh, no, it does not work, this one, right? So it is a fraction. I mean, come on, hey, look at it. That's a fraction. So I'm not sure why the previous one works and this one doesn't work, but these are the limitations of your calculator. Please, you do number 10, 11, and 12. Let me move on. So here I have to use the sigma notation to write this sum. So the first one is pretty simple. I'm gonna go from I equals 1 to, well, 100, and my general term is just I. Okay, that's very, very simple. Well, what about the second one? Now you're adding all the odd terms between 0 and 100, or between 1 and 100, right? So how do we write that? Well, an odd term is 2i plus 1, right? If I takes any value, this is going to be odd, right? So where are you starting? Well, let's see. The first one has to be 1, so I has to be 0. And what's the last one? Well, you want 2i plus 1 to be 99. That means 2i has to be 98, and so I has to be 49. So from I equals 0 to 49. That's it. and here you will have all the odd terms. So how many terms right here do you have? 100. How many terms do you have right here? 50, right? From 0 to 49 you have 50 terms. Okay, please do number 15 and 16. I'm gonna do number 17. So in number 17 we have to write this using the sigma notation. So it's gonna be sum from here, let's call it k this time. K equals, well, I'm not sure here, I need to see. Okay, so you have 1/2, 2/3, 3/4, 17 18th. So obviously it is k over k plus 1, or if you wanted you could write k minus 1 over k. You could even write k plus 1 over k plus 2, but then you would have to change the limit, the lower limit and the upper limit. I'm going to use this one right here, k over k plus 1. Now where do I start? Well, look, you start at 1, right? K equals 1. Where do you stop? Well, you want k to stop at 17. Here we go. Actually, let's write this sum another way now using this general term. So it is sum from k, and I'm not sure what it's going to be equal to, but it's of k minus 1 over k. All right. So here, I'm going to be looking at this one now, right? And this one tells you, this is this one right here, k equals 2. You start at 2. Right here, right? And if you start at 2, then at the top it's 1. Okay, that works fine. Now k equals 2, and where do you finish? You finish at 18. From k equals 2 to k equals 18. So these two sums are absolutely the same. Okay, let's move on. Please do number 18. I'm going to do number 19. So we have to write this decimal number with a sigma notation. Ooh la la, how do we do it? Well, check it out. It's not difficult. Let's rewrite this number. This is 1 plus 6/10, right? That's 0.6. Plus, well, okay, what's this one now? This is 6 over 100, right? Okay, so now let's look at this one. Plus 6 over 1,000, right? So the next one is going to be 6 over 10 to the 4th, 10 to the 5, and 10 to the 6. Plus 6 over 10 to the 5 plus 6 over 10 to the 6. Right here, right? Does that make sense? So how do we write this using a sigma notation? Well, it's pretty simple. It's going to be sum from, I'm going to use I here. I equals, okay, we'll see how to write that. So you see right here, it's a bit challenging. I mean, I would like to write 6 to the power of 10 to the I, right? But the problem with this is that I don't get this 1 plus right here. This 1 could possibly be a power 0, but 6 is not inside the power. You don't change the power of 6. So I'm not sure what to do right here. I think I'm going to do this, and maybe one of you will find a smarter way to do it. But for now, I'm gonna write it like that. I equals 1 to 6. Here we go. I'm going to write it like this, and that's fine. So it's not a full sigma notation. I have this 1 plus right here. Okay, please look at the last two properties I wrote at the bottom of the set of notes. They are just the generalization of the property that you know. Basically, it says that you can reorder the terms like A1 plus B1 plus A2 plus B2, right? You could write that as A1 plus A2 plus B1 plus B2. That's the first property right here. And then the other one says that when you have like K times A1 plus K times A2, you can take out K, you can factor it, and it's K times A1 plus A2. Please check out the two properties. They are pretty simple. Thank you for watching.